Hello dear all, welcome to the another video of our course, that is Discrete Mathematics, and today we are going to discuss the algorithm called Warshall algorithm. In our previous video we have discussed about the transitive relation, and this transitive relation is little tricky as compared to other relations. So here in this video we are going to discuss an algorithm called Warshall algorithm, which will help you to find whether relation is transitive or not. So in our previous video we have discussed about the transitivity, and a relation is said to be a transitive if AB belongs to R and CB also belongs to R, then AC must belong to R. If you haven't watched my previous video where I have discussed about the transitive relation, you can watch it from my playlist. So in our previous video we have seen that, or we have discussed that we need to check our transitivity in two cases. These are the two cases, case 1 and case 2. So in case 1 we have these elements are common. This first element of second element of first pair and the first element of second pair is common, then we need to check for AC. Then in second case these two elements are common. So such case occurs, then only we need to check for transitivity. Otherwise, by default, our relation is transitive. So in this video, we are going to discuss the Warshall algorithm, which will help you to find the relation, whether the relation is transitive or not. So this Warshall algorithm is little lengthy, and I personally suggest you to use this Warshall algorithm only if you are not sure about whether the relation is transitive or not. If you are able to identify, or you are able to identify the relation is not transitive, then it's better not to use this Warshall algorithm. But the Warshall algorithm is very useful when we have confusion whether the relation is transitive or not, then we can use this Warshall algorithm. So here in this video I am going to discuss the Warshall algorithm. So consider this is our set A, and which contain three elements, 1, 2 and 3, and this is our relation where we need to check for transitivity. So by direct method we try to check whether the relation is transitive or not by our direct method. So here in this relation we have this 2 is common, so we must need to have another pair, that is 1 and 3. So we have 1 and 3 here. So here in our another relation, so this 2 is common, so we must need to have 1 and 2. But here we don't have 1 and 2, therefore this relation is not a transitive relation. So we can identify this relation is not a transitive, then we don't need to use Warshall algorithm. But for practice I'm going to present the Warshall algorithm on this relation. So in such case, if we are easily able to find whether the relation is transitive or not, is better not to use Warshall algorithm. For practice purpose I'm going to explain the Warshall algorithm in this relation. So in our Warshall algorithm, first we need to create our matrix for this relation. So this is our matrix. Here in this matrix, this represent our column and this is our row, and the number of columns and number of row equals to number of elements in our set. We have how many elements? 1, 2, 3. So we have 3 columns and 3 row, and this 1, 2, 3 are the elements of this set A, and this 1, 2, 3 is the element of this set. So if we have n element, then our matrix will be n into n. So n into n. So we have 3 elements. So we have our matrix will be 3 into 3. So these are the 1, 2, 3 is the element of our set A, and this is our set, elements of our set. So this is our column and this is the set. So this is the number of elements equals to the n into n. So we need to put 1 on those cells which contain those cells where we have our our relation, where our elements of our relation is there. So this is our 1. So we have put 1 here, 1 here, 1 here. So we have 1, 1. So we need to put 1 and 1. So here we need to put 1. So another element is of our relation is 1, 3. So we need to put 1 and 3. So here we need to put 1. And another relation element of our relation is 2, 3. So we need to put 2. So another is 2. Sorry, 2, 2. So this is 2 and 2. So we need to put 1 here. So another element is 3, 1. So this is 3 and 1. So we need to put 1 here. So another element is 3 and 2. This is our 3 and this is our 2. So we need to put 1 here. So this is 3 and 2. 1 and 1, 2 and 2, 3 and 1, 3 and 2. So this is how we need to put 1 on those cells which contain on relation, and we need to put 0 on the remaining cells. So this is our first step. Now we need to create a table where 1, 2, 3, because we have 3 elements, so we need to create table with 3 column, 1, 2 and 3. And then we need to write C and R. C stand for column and R stand for row. So this is our column and this is our row. Then we need to, so this is the 1, 2 and 3 is the column because we have 3 elements, and this is the column and row. Now we need to put then we need to check for column 1. So this is our column 1. So we have in column 1, so this is our column 1. So we have 1 on 1 and 3. So in 1 and 3 we have 1. So we need to write 1 and 3 here. So in column 2 we have, in column 2 we have 1 on, this is our column 2, this is our column 2, and we have 1 on, here is 2 and 1 on 3. So we need to write here 2 and 3. In our column 3 we have 1 only on this cell 1. So we need to put 1 here. So this is for our column. And now we need to check for row. So this is the row and this is the column. So now we are checking this row. So we have 1 on 1 and 3. So we have 1 on 1 and 3. So we need to write here 1 and 3. So in our second row we have 1 on this 2. So this is we are checking this row. So we have 1 only on this 2. So we need to write 2 here. Now we are checking this row. So we have 1 on 1 and 2. So here we have write 1 and 2. So this is how we need to fill our table. Then we need to find the Cartesian product with, then we need to find the Cartesian product. So C cross R. So we need to find C cross R. So 1 and 3 and 1 and 3. We need to find the cross product. So we have 1, 1. So cross product. So this is, so we need to find cross product. So cross product with 1 and 1. Then 1 with 3. 1, 3. Then 3 and 1 and 3 and 3. So this is our cross product. And then we need to find the cross product with this and this. So we have 2, 2 and we have 3 2. So these are the cross product of this, and now we need to find the cross product of this and this. So we have 1 1, that is 1 1, and we have 1 2. So this is our cross product. So this is the cross product of set C and R. Now we need to check these elements are there in our relation or not. If any of the elements are not present in this relation, then our relation is not a transitive relation. So here we have 1 1, so we have 1 1 here. Here we have 1 3, so we have 1 3 here. Here we have 2 2, so we have 2 2 here. Here we have 3 2, so we have 3 2 here. We have 1 1, so here we have 1 1, and we have 1 2 here. So we don't have 1 2 in this relation, so we don't have this 1 2. Therefore this relation is not a transitive relation. And here we have 3 1, so we have 3 1, and we have 3 3, but this 3 3 is not present in this relation. Therefore our relation is not a transitive relation. So this is how we can use the Warshall algorithm to check whether the relation is transitive or not. So I'm going to repeat this